Solving literal equations. A literal equation is an equation in which known quantities are expressed, either wholly or in part by using letters. A good example is speed equaling distance divided by time, which you may have seen in your physics course. Another example is area is equal to pi times the radius squared, which we use when studying geometry. In some cases, it is actually easier to work with literal equations since there are only variables and no numbers. Our goal is to be able to solve any equation for any variable that appears in it. Let's look at a simple equation first, speed equaling distance divided by time. The variables in this equation are s for speed, d for distance, and t for time. Solving for a variable means having it alone or isolated. This equation is currently solved for s, or the speed. When solving a literal equation, you will be asked to isolate a particular variable in the equation. For example, with the equation interest being equal to principal times the rate times the time, you may be asked to solve for the principal amount, or lowercase p. This means that p will be on one side of the equation by itself. The new formula looks like this. P, or the principal amount, equals I, the interest, divided by the quantity rate times time. You can transform a formula to describe one quantity in terms of the others by following the same steps as solving an equation. Solve the equation for W, or the width. We have the equation V equals L times W times H, which represents the volume of a rectangular prism, and that volume is length times width times height. We have to first notice the operations that are going on between the length, width, and height on the right side of our equation, and that's multiplication. So in order to solve for the width, we have to do the inverse operation of multiplication, which is division. We're going to divide both sides by the length times the height. And when we do that, the length will cancel out and the height will cancel out on the right side of the equation, and therefore the width is equal to the volume divided by the quantity length times height. Solve the equation for d, or distance. We have our speed equals distance divided by time equation, and in order to solve the equation for distance, we would multiply both sides by the time. That'll allow us to cancel out the time values on the right-hand side of the equation, leaving us with d for distance by itself. So we have that distance is equal to speed times time. Solve the equation for v sub 0. We have v for velocity is equal to v initial, the initial velocity, plus acceleration times time, at. In order to solve this for v initial, or v sub 0, we're going to subtract the at to both sides of the equation, or from both sides of the equation. And when we do that, we will end up getting that v initial is equal to v minus a times t. And then we can also rewrite it with v initial on the left-hand side of the equation, and it remains the same. Literal equation questions may be posed in various ways. Regardless of the way, the equation will still require you to isolate a variable. You may encounter some of the following phrases. Which equation is equivalent? Solve for blank in terms of blank. Isolate the variable, whatever that variable is. Transform the formula to find whatever the desired variable is. Blank is given by whatever scenario you encounter. Remember, the steps for solving all remain the same.